This is the homework for tonight, number 5 in the reaction as follows. What mass of the product can be formed by combining 55 grams of BaCO3 and 26 grams of HNO3? So we have the same reaction written out there and a for every statement. Now if you're starting with 55 grams of this coming from 197 grams, what the conversion factor would be 3.5. So if we're trying to see how much of the product 55 grams of BaCO3 creates, we would do the same thing to the product that we're trying to find using the same conversion factor. So we would divide that by 3.5. Actually, it should be the grams. And if you divide that by 3.5, you get 74.5 grams of that product. Now, it also says that if you're using 26 grams of HNO3, so to get from 126 to 26, you're dividing by 4.8. Whatever you do there, you do the same thing here. And what you would get from that is 54.3 grams of the product. So the first part of the question is figuring out which is the limiting reactant. So when we look at HNO3, it produces 54.3 grams, and when we look at BaCO3, it ends up producing 74.5 grams. So we know that the green, being lesser, means that this is our limiting reactant for this problem. So now that we know it's the limiting reactant, that's going to be the one we're going to use to calculate the product. And we already did. So the answer for number 5 should be 54.3 grams. For question 10a, the balancing of the equation as it stands. The coefficients for everything should be as follows for the balanced reaction. With question 10b, it tells you that you have a different amount of moles for aluminum and sodium hydroxide. You have 0.57 moles for aluminum, and you have 0.37 moles of sodium hydroxide, and it's asking for how much H2 it produces. So first you need to figure out, based off of the 2 moles you have, which is the limiting reactant, and we do that the same way. So in getting from 2 to 0.37, what we did was divide by 5.4. So we would divide 3 by 5.4, and what we get is 0.56 moles of H2. Now we don't know whether that's the limiting reactant or not because we don't know how much aluminum would produce. So going from 2 to 0.57, we divided by 3.5, and in doing the same to 3, we end up with 0.85 moles. So now you have 2 different numbers for what the reactants would create in the products, and we can see that the lesser amount being in the green means that sodium hydroxide is the limiting, and that is how much 0.56 moles of H2 is produced in this reactant. For question 11a, it's asking for how many moles of HNO3 and how many moles of Cu need to react in order to produce a total of so many moles of NO2. So you have 0.0845 moles. The conversion factor from 2 to that number is a division of 23.6. Using our for every statement, we would be able to calculate how many moles exactly we need of HNO3. which is 0.169, and for the moles of copper, which would be 0.0422. So those are the two moles for Cu and HNO3 for 11A. For question 11B, I'm going to be using the same for every statement. I just wrote the molar masses of both those molecules, including the coefficients, in parentheses underneath it. So for letter B, it says there's 5.94 grams of Cu. So this is going to 5.94. And for HNO3, it says that there's 23.23 grams. Based off the conversion factor for these, we would find that this is dividing by 10.85, and the green, or the Cu, is dividing by 10.69, a factor of. So if we were to look at the reactants and check the product, looking at the product, 2 moles of NO2, if we were to use the conversion factor of Cu, we would be dividing by 10.69, and what we would get for that is 8.60 grams. And if we were to use the one that we got for HNO3, it would be 10.85 dividing by, and you would get 8.47 grams. So because this is the lesser of the two, this is the limiting reactant, and the Cu would be the one in excess because it is the reactant that does not get taken completely. For number 12, we have our reaction right there. And for letter A, it says if you have 2.9 moles of NH3 and 3.75 moles of O2, how many moles of each of the product are formed? So the first thing we're going to have to do is figure out which one of those between NH3 and O2 on the reactant side is the limiting one. And once we know the limiting, then we can figure out, based off the conversion factor, how much of each of the product is formed. For letter A, you're starting out with different amount of moles of the reactants, not grams. It's nothing to be confused about because it's pretty much the same thing between moles and grams. It's just another way of expressing a term. So going from 4 to 2.90 moles of NH3, you're dividing by 1.38. And if you were to do that to the reactant, divide by 1.38, what you would end up with is 2.89 moles. And if you did the same thing with the green, or the oxygen, you would find that you're dividing by 1.3 as a factor. And if you were to divide that by 1.3, what you would end up with is 3.07 moles. So the lesser of the two is the red. So what we know now is that NH3 is the limiting reactant as far as this problem is concerned, and the O2 is the excess. And we've also found the moles of NO, which is 2.89 or 2.9 moles. So to calculate the moles of the other product, H2O, we would take the moles of that and do likewise, divide by 1.38, and we should get around 4.35 moles of H2O. So that's letter A. For letter B in number 12, we have different amounts of grams of the two reactants. It's written out in scientific notation, so just be careful how you do it on the calculator. And when you see that it's 10 to the fourth, another way of writing this out, you would just move the decimal place 4 zeros. I take that back, you would actually move the decimal place 4 times period, not 4 zeros. So you would go 4.2, 1, 2, 3, 4. So you should have 42,000 grams for the NH3, and for the O2 If you have 1.31, 1, 2, 3, 4, 5, you would have 131,000 grams. So if that makes it look easier for you. Once we figure out the factors from going from the molar mass of either of the reactants to the amount that we have, we multiply that by one of the products, and what we find is that the one in the red, NH3, is the one that limits. So NH3 limits. Letter C, we have two different masses, kilograms. I have them written down easier way. You're figuring out the conversion factor, you're doing the same thing, and what you find is NH3 limits, because this is the lesser amount, and because we chose the right product, that is the answer for letter C.